I want you to imagine, just for a second, walking into a busy, like, modern corporate office.
Okay.
And right there, sitting openly on a front reception desk where literally anyone can walk by, are massive stacks of $100 bills.
Oh, wow.
Just sitting there, no guard, no camera, no lockbox, just cash catching the breeze from the air conditioning.
You would obviously never do that in the physical world.
Right. You would never do that. But in cloud architecture, developers leave the digital equivalent of cash on their desks, like every single day.
Yeah, they really do.
So today, we are cracking open some AWS exam blueprints, specifically the SAACO3 Solutions Architect notes, alongside some DevOps survival guides, to figure out how to lock that cache in a vault.
It's an incredibly high-stakes topic.
It is. Welcome to today's deep dive, everyone. Our mission here is to demystify DevOps secrets management. Basically, managing digital credentials is all about taking that exposed cache and moving it into a highly secure, heavily guarded bank vault with strict audit trail.
And it's a critical shift in perspective, right? Because in the physical world, risk is tangible. You can physically see the cache on the desk. You can see the open door.
Exactly.
But in cloud architecture, the risk is completely invisible. You're dealing with strings of text hidden inside, like thousands of lines of code. And until you realize the true value of those text strings, you don't even realize you've left the vault wide open to the public.
Okay, let's unpack this right out of the gate. Because if you are just catching up on your DevOps basics, or, I don't know, maybe you manage a team and you keep hearing this terminology thrown around in planning meetings, the word secret sounds very dramatic.
Right, like spy stuff.
Yeah. We aren't talking about, unreleased product rumors here. So what exactly constitutes a digital secret in this specific context?
Well, in cloud infrastructure, a secret is basically any piece of data that acts as a key to unlock a protected resource programmatically.
Okay, so like API keys.
Exactly. API keys, which allow one piece of software to authenticate and talk to another piece of software. Or database passwords that grant access to your entire customer database.
Oh, right.
Private encryption keys, authentication tokens, all of that. If a piece of text can be used to, authenticate an identity or authorize an action within your infrastructure, it is a secret.
It's the digital equivalent of a master key to your company's headquarters.
Spot on. That's exactly what it is.
So the absolute nightmare scenario, the equivalent of leaving that master key sitting on a park bench, is what developers call hard-coded credentials. This is when someone literally types that password or API key directly into the application's source code, right?
Yes, that is the most common vulnerability, hands down. And it brings us to a real-world disaster scenario that's actually outlined in our source materials.
Okay, let's hear it.
So a developer is working late, right? Trying to get a new feature to function properly. They need the application to talk to an Amazon Web Services database. And just to get the test to pass quickly, they paste the AWS Access Key directly into the code.
Oh, no.
Yeah, it works. They're exhausted, so they commit the code to their Git repository, and they push it up to GitHub. They're probably thinking, I'll clean this up in the morning.
But they accidentally push it to a public repository rather than a private internal one.
Exactly.
And the sources note that this specific type of mistake has ended up costing companies thousands of dollars in mere minutes.
But I have to push back on that timeline a little bit.
Sure.
How does a leak cost thousands in minutes? I mean, GitHub is massive, right? There are billions of lines of code hosted there. What are the odds that a malicious hacker happens to be sitting there manually refreshing that specific developer's page at that exact moment?
Well, that's what's so fascinating and terrifying here. It's the sheer scale of automation on the dark web. There are no humans manually refreshing pages.
Really?
Not at all. Bad actors have built these incredibly sophisticated automated bots that are plugged directly into the public feeds of platforms like GitHub.
They are constantly scraping every single new line of code being published globally the second it goes live. Yeah. And they use something called regular expressions to do it.
Regular expressions. Okay, think of those that like a highly specific mathematical search filter, right?
Yes, exactly.
The bots aren't reading the code like a book. They are scanning the matrix specifically for the recognizable shape and format of an Amazon Access Key. It's like, I don't know, scanning a crowded stadium just for people wearing a very specific neon name tag.
That is a great way to look at it. Amazon Access Keys typically start with standard prefixes like IKEA.
Okay.
So the bots see that recognizable string, they grab it, And within literally milliseconds, they automatically execute scripts to spin up dozens of massive, highly expensive server instances inside your AWS account.
And what are they doing with those servers once they spin them up?
Almost always, they use these high-powered servers to mine cryptocurrency.
Oh, of course.
Yeah. By the time the developer realizes their mistake, maybe an hour later when they get a coffee, the bot has already...
Okay, but I mean, usually in enterprise tech, free means bare minimum. We're basically just hiding the key under the digital doormat here.
It's natural to be skeptical of free security tools, for sure. But SSM Parameter Store isn't just obfuscating your text. It utilizes a feature called Secure String, which is directly paired with AWS KMS.
Let me jump in there just to clarify for anyone who hasn't lived in AWS recently. KMS is the key management service.
Right.
And when you say it pairs with it, that involves IAM permissions and encryption at rest, right?
Yes, exactly.
Because IAM is identity and access management, basically the digital bouncer checking the application's ID at the door. And encryption at rest just means the data is mathematically scrambled while it's sitting on the hard drive, not just when it's moving across the internet.
Yes, you nailed it. And the way those pieces interact is what makes it so robust. When you store a database password as a secure string, it is encrypted at rest using a KMS key.
Oh,
So even if a bad actor manages to somehow look inside your parameter store database, all they see is scrambled, completely unreadable ciphertext.
right, just gibberish to them.
Exactly. To actually read the secret, the application doesn't just need access to the parameter store. It must also pass that IMM bouncer you mentioned. It has to have explicit cryptographically verified permissions to use that specific KMS decryption key.
Wow.
So you are getting military-grade encryption in a highly secure safe deposit box entirely for free.
So if SSM Parameter Store is giving me military-grade encryption for free, that raises an obvious question. Why on earth would any company ever choose to pay for a different AWS tool?
And that leads us to the Premium Vault, AWS Secrets Manager. Our sources are very specific about the cost here.
Okay, what's the damage?
AWS Secrets Manager costs 40 cents per secret per month, plus, a few cents for the API calls.
I mean, if you are listening to this and you're running a massive microservice architecture with thousands of rotating keys across multiple staging and production environments, that 40 cents suddenly looks like a hefty line item your CFO is going to ask about.
It definitely adds up.
So what are you actually buying for that 40 cents?
You are buying automation, specifically a capability called native rotation. Secrets Manager has deep native integration with AWS RDS, the relational database service.
Okay, I follow.
What this means is that Secrets Manager can automatically change your database passwords for you on a regular schedule, say every 30 days, without any human involvement whatsoever.
Let's talk about why that matters, because manual rotation is an absolute nightmare.
Oh, it's the worst.
If you use the free parameter store, changing a database password means a human has to write the scripts, log into the database, change the password, update the parameter store, and crucially restart or update every single live application that relies on that database so they have the new password.
Yes.
If you mess up the timing on that, your entire application goes down.
The operational overhead is just massive.
Yeah.
And the risk of human error causing an outage is so high.
Right.
Secrets Manager handles all of that heavy lifting natively. It securely generates the new secret, updates the database backend, and ensures the applications pull the new passwords seamlessly.
So Secrets Manager is like a bank vault that automatically changes its own locks every 30 days and then hands the new key directly to the armored car driver without you ever having to hire a locksmith or even know that the lock was changed.
That lock-changing analogy perfectly captures the mechanism. The vault just manages its own life cycle.
Here's where it gets really interesting, especially for those listening who are prepping for their AWS certifications. Our sources lay out how professionals actually choose between these two vaults using a very clear decision matrix.
Right, cost versus rotation versus features.
Exactly. And to make this concrete, the sources provide scenarios pulled straight from the perspective of the AWS SAAC03 exam. Let's walk through these.
These scenarios are excellent for testing if you actually understand the core differentiators. Let's look at scenario 1. An application running on AWS requires its database credentials to be automatically rotated every 60 days to comply with corporate security policies. Which service is required?
Based on what we just discussed, the key phrase there is automatically rotated. Since Parameter Store requires manual scripting for that, the answer has to be the Premium Vault. It's AWS Secrets Manager.
The native automatic rotation is absolutely the trigger word for Secrets Manager. Now, let's do scenario 2. A development team needs secure storage for several API keys. The project is internal, has a strict zero-budget constraint for secrets management, but still requires robust encryption at rest. Which service should they choose?
Zero budget constraint is the giveaway there. They need it to be free, but they still need that KMS encryption at rest. So that's going to be the SSM Parameter Store using secure string.
Exactly. You are balancing the functional needs against the constraints of the business.
What I love about this is how perfectly these exam scenarios map to real-world business decisions. You can easily picture sitting in a conference room where the CFO is demanding the zero-budget option from scenario 2, while the Chief Information Security Officer is pounding the table demanding the auto-rotation from scenario 1.
Oh, happens every day.
It really proves that these certifications test practical survival skills, not just theory.
It forces you to match the tool to the operational maturity and budget of the organization. But, of course, the cloud landscape isn't always neatly contained within a single provider like Amazon.
Right. What happens when a company outgrows a single ecosystem? Let's say a listener's business isn't just using AWS. Maybe they have some legacy servers on premises, they use Google Cloud for their data analytics, and AWS for their web hosting.
Very common setup.
Yeah, so they have their cache spread across multiple different banks.
Yeah.
What do?
When you hit that level of enterprise complexity, our architectural sources introduce a third major player, HashiCorp Vault.
Okay.
This is a third-party enterprise-grade tool. What it adds over the AWS native tools is, first and foremost, cloud-agnostic secrets management. It acts as the central singular vault for AWS, Azure, Google Cloud, and private data centers.
That makes sense.
But the most groundbreaking feature it introduces is the concept of dynamic secrets.
Dynamic secrets. Okay, let's unpack this. How does a secret become dynamic?
Well, think back to Secrets Manager. It rotates an existing password every 30 days, right?
Right.
A dynamic secret doesn't rotate. It is generated entirely on the fly, precisely at the moment an application requests it, and it is given a strict time to live.
Wait, really? On the fly?
Yes. Let's say your web server needs to read data from a database. Instead of looking up a static password, the server asks HashiCorp Vault for access. Vault dynamically creates a brand new database user and password that has never existed before, hands it to the server, and sets it to automatically self-destruct in, say, 5 minutes.
Oh, wow.
The server runs its query, and 5 minutes later, those credentials simply cease to exist.
So it's like a self-destructing VIP pass.
Exactly.
That is brilliant, because even if a hacker somehow intercepted that password, by the time they try to use it, it's already gone. It fundamentally changes the game from how do we guard the key to how do we make the key completely worthless to steal.
It's a huge paradigm shift.
But I have to push back here. Dynamic secrets sound great in theory. But if a vault is generating new credentials every 5 minutes for every single microservice, doesn't that create a massive performance bottleneck?
It's a valid concern.
And what happens if HashiCorp Vault goes down? Doesn't your entire company just grind to a halt?
The trade-off there is substantial, and you've hit on the exact reason HashiCorp Vault is considered an enterprise-grade tool. It requires a highly available, robust architecture to run. If Vault goes down, yes, your services cannot authenticate.
Yikes.
So enterprises deploy it in highly available clusters across multiple geographic regions. The performance bottleneck is actually mitigated by how lightweight the generation process is, but it absolutely requires dedicated engineering teams to maintain. It is not a plug-and-play solution like Parameter Store.
That makes a lot of sense. You are trading operational simplicity for absolute zero-trust security, which makes Scenario 3 from the exam blueprints pretty obvious.
Let's hear it.
Scenario 3 reads, a massive enterprise operating across AWS, Azure, and private data centers requires a centralized secrets management solution. The security team mandates that all database credentials must be generated on demand and automatically revoked immediately after use to ensure maximum security. What is the appropriate solution?
And your analysis.
The triggers there are across multiple clouds and generated on demand and revoked. That is the exact definition of a dynamic secret, so the answer is HashiCorp Vault.
Exactly. It is the only tool discussed that handles that specific, highly complex requirement across multiple environments.
So what does this all mean for the actual day-to-day workflow? Because having these amazing high-tech vaults is technically useless if a developer still has to manually copy and paste the secret from the vault into the application code.
Right, that defeats the purpose.
If I am setting up an automated pipeline, say GitLab CI/CD, I assume the goal is to get the secret into the pipeline without ever writing it to a file. Is it just injecting it as an environment variable in the machine's memory?
You are hitting on the crucial bridge between storage and execution. Our DevOps best practice sources heavily emphasize CI/CD integration. And yes, the mechanism is injecting it directly into memory, but the vital part is how the pipeline proves its identity to the vault to get that injection.
Wait, how does a piece of code prove who it is without using a password to do it?
It uses short-lived identity tokens or native IAM roles. The GitLab pipeline sends a cryptographic signature to AWS or HashiCorp Vault, essentially saying, I am the authorized deployment pipeline for Project X.
Okay.
The Vault verifies that signature against its policies. Once verified, the Vault dynamically injects the required secret directly into the pipeline's secure memory space, its RAM, just for that specific deployment run.
So it's like a briefcase that incinerates the cache the second it's handed over and used.
That's a great image,
The
yes.
secret never touches plaintext. It never gets written to a log file. It never gets saved to a hard drive where it could be accidentally committed to GitHub.
Exactly. The secret exists in the machine's memory just long enough to authenticate the deployment, maybe running a Terraform script or deploying a container, and then the container dies and the RAM is wiped clean.
And that right there is why you should care about this, whether you are writing code, studying for your SAAC03, or managing the people who do. This is the ultimate goal of modern DevOps. Machines securely talking to other machines, proving their own identity, completing their tasks, and wiping the slate clean. It entirely removes human error completely out of the equation.
It creates a system where the easiest way to deploy code is automatically the most secure way to deploy code.
So let's synthesize this journey we've been on. We started with the absolute nightmare of leaving cache on the desk, a leaked key on GitHub costing a company thousands of dollars in minutes because automated bots are constantly scanning for regular expressions.
The worst case scenario.
Right. To stop that, we looked at the free KMS-backed security of SSM Parameter Store for those zero-budget projects. Then we upgraded to the premium AWS Secrets Manager to eliminate the operational nightmare of manual password updates with automatic RDS rotation.
Yep.
And finally, for the massive multi-cloud enterprises, we scaled all the way up to HashiCorp Vault to utilize dynamic, self-destructing secrets.
You know, if we connect this to the bigger picture, there's a fascinating trajectory here.
Oh,
We are moving from static passwords humans have to remember, to automated rotation, to dynamic secrets where machines generate, use, and destroy their own passwords in milliseconds without any human intervention.
yeah, that's true.
It raises a thought experiment. Are we rapidly approaching a future where human developers are intentionally, fundamentally locked out of their own production environments entirely?
Oh.
I mean, if perfectly secure architecture relies on secrets that exist only for a millisecond between machines, the logical conclusion is that the human element is the only remaining vulnerability. We are building vaults so advanced that soon we won't even be allowed to hold the keys to the systems we build.
That is a massive paradigm shift from protecting our access to removing our access entirely in the name of perfect security. That is definitely something for all of you to chew on during your next deployment. Thank you for joining us on this deep dive into the architecture of secrets management.
It's been great.
Before you push your next update, maybe take a quick second to double-check those code repositories. Make sure you aren't leaving any cache on the desk. We will catch you next time.